My name is Peter Matherin, and my project is Radio Telescope. Or shall I say, I played a key role as one of the scientists when Panzia and Wilson discovered cosmic microwave radiation. Um, what what we tried, what we're trying to find. That's a good question. Let me give you a background first so that you can have an idea where we're going. So in 1950s, there were essentially two theories about the origin of the universe. So one was the steady state theory, which held that the universe was homogeneous in space and time and will remain so forever. The more controversial theory sought to incorporate Edwin Hubble's discovery in 1929 that galaxies are moving away from one another at remarkable speeds. A handful of scientists, physicists led by George Gamow, argued that the separation between galaxies must have been smaller in the past, which meant that at some point the universe had once been infinitely dense. Everything in the universe had emerged from this incredibly dense and hot state in a cataclysmic explosion called the Big Bang. Bell Labs built a giant antenna in Holmdel, New Jersey in 1960. It was part of a very early satellite transmission system called ECO. By collecting and amplifying weak radio signals bounced off large metallic balloons high into the atmosphere, it could send signals across long distances. Within a few years, the Telstar satellite was launched. It had built-in transponders and made the ecosystem obsolete. Meanwhile, two employees of Bell Labs had their eyes on the antenna. One name is Arno Penzias. He was born in 1933. He's a German, a radio astronomer. A radio astronomer. Sorry. He joined the Bell Labs in 1958. He had done his PhD on using masers. By definition, is a microwave amplification by stimulated emissions of radiation to amplify and measure radio signals from the spaces between galaxies. He knew about the antenna. He knew that the antenna will also make a great radio telescope and was dying to use it to continue his observations, but he kind of pursued other research agent while the antenna was being used for different purposes, right? But another radio astronomer came to Bell Labs in 1962 with the same idea. His name is Robert Wilson. He was born in 1936. He had also used masers to amplify weak signals in mapping radio signals from the Milky Way. So the launch of Telstar in 1962 gave both researchers what they actually wanted, which was to use the antenna for research purposes. So when they began to use it as a telescope, they found there was a background noise, like a static in a radio. This annoyance was a uniform signal in the microwave range, seeming to come from all directions. Everyone assumed it came from the telescope itself, which was not unusual, but it hadn't interfered with the ecosystem. But Piensis and Wilson had to kind of find a way to get rid of that noise to make the observations they planned. They checked everything to allow different kind of options, but the noise was still there. They pointed to the antenna right at New York City. It wasn't urban interference. It wasn't radiation from our galaxy. It wasn't even pigeons living in the big horn-shaped antenna. So the source remained the same through 4 seasons. So it couldn't have come from the solar system or even from 1962 above-ground nuclear tests, because in a year that fellow would have shown a decrease. So they had to conclude it was not the machine, it was not random noise causing the radiation. Penzias and Wilson began looking for theoretical explanations. Around the same time, Robert Dickey at nearby Princeton University had been pursuing theories about the Big Bang. He had elaborated on existing theory to suggest that if there had been a Big Bang, the residue of the explosion should by now take the form of low level background radiation throughout the universe. Dickey was looking for evidence of this theory when Panzia and Wilson got in touch with his lab. Ironically, Robert Wilson had been trained in steady-state theory, which suggested the universe was without beginning or end, unlike Big Bang theory, and he felt uncomfortable with the Big Bang explanation of their radio noise. When he and Panzia jointly published their research with Dickey, the Bell Lab researchers were just kind of interested in just the facts, so they simply recorded observations. The measurement of cosmic background radiation, as the Helmdale telescope's noise is now called, combined with Edwin Hubble's much earlier finding that the galaxies are washing away, makes a strong case for the Big Bang. By the mid-1970s, astronomers called it the Standard Model. Arnold Panzia and Robert Wilson received the Nobel Prize in Physics in 1978. Where the project occurred, it was New Jersey. Like I mentioned many times during the first questions, it was in a city called Holmdel. Other significant events that were happening at the time, America was involved in a war in Vietnam. So you can imagine that the country was very divided at the time, and a huge portion of the population was very against that war. So it was very difficult for scientists to get research grant and in the light of those circumstances. So the people that were involved in this project was Robert Dickey, Edwin Hubble, and my specific role in this project was I was like a human computer scientist. They call it. I collected the data. I provided that was provided to me, and I conducted any kind of complex calculations. I was very gifted in this field. I could handle any kind of number thrown at me. That's exactly what I've done in a very limited time. So that's what was required of me. The impact that the project had in the physics community, it had tremendous impact. It made it possible to obtain information about cosmic processes that took place about 14 billion years ago, and forever changed the science of cosmology, transforming it from a specialty of select few astronomers to a respectable branch of physics almost overnight. And finally, do I think that they receive enough credit for their work? I would say yes and no, because Panzia and Wilson had, yes, because Panzia and Wilson had received a Nobel Prize for their work, but no, because unless you are part of the scientific community, they have little to no recognition from the rest of the world.